A lithium-ion battery can move a car, power a laptop, or keep a phone alive all day. Yet inside the cell, almost nothing looks like it is moving. The secret is that a battery does not really store electricity like water in a tank. It stores chemical potential. When the battery works, lithium ions move inside the cell, while electrons are forced to take a different route, through the device you want to power. At the heart of a typical lithium-ion cell are four essential parts: a negative electrode called the anode, a positive electrode called the cathode, an electrolyte that carries ions, and a separator that keeps the electrodes from directly touching. Imagine the battery is charged. Many lithium ions are held in the anode, commonly inside layers of graphite. The battery now contains stored chemical potential. Connect the battery to a circuit, and the system begins to discharge. Lithium atoms at the anode give up electrons. The lithium ions can travel through the electrolyte toward the cathode. But the electrons cannot simply cross the electrolyte and separator. They are pushed through the external circuit instead. That detour is the useful part. The moving electrons can light a screen, turn a motor, or run a processor before arriving at the other side of the battery. Inside the cell, lithium ions reach the cathode and help balance the charge. So two flows happen together: ions through the battery, electrons around it. Charging reverses the process. A charger supplies energy and drives electrons back toward the anode through the external circuit. Lithium ions move back through the electrolyte and are stored again in the anode material. This back and forth movement is why the battery is rechargeable. The electrodes are designed with structures that can repeatedly host lithium ions, a process known as intercalation. But this elegant shuttle only works because the materials are carefully separated. The electrolyte must let lithium ions move. The separator must also allow ionic transport, while preventing the anode and cathode from touching. If the electrodes make direct electrical contact, the cell can short-circuit. Energy may be released rapidly as heat, and that reveals the central engineering tension of lithium-ion batteries. We want a lot of energy packed into a small, light object, but concentrated energy has to be controlled. The modern lithium-ion battery emerged from decades of materials research. In the 1970s, Stanley Whittingham demonstrated a rechargeable lithium battery using a material that could host lithium ions. John Goodenough later showed that a cobalt oxide cathode could produce much higher voltage. In the 1980s, Akira Yoshino developed a practical design using a carbon-based anode instead of reactive metallic lithium. Their work was recognized with the 2019 Nobel Prize in Chemistry. Those breakthroughs turned ion movement into an everyday technology. But rechargeable does not mean permanent. Real batteries slowly change. Side reactions consume usable lithium and alter interfaces. Repeated cycling, high temperatures, high states of charge, and demanding power can accelerate degradation. Over time, the battery stores less energy and its internal resistance can increase. That is why battery management matters. Phones and electric vehicles do not treat a battery as a simple box of energy. Electronics monitor voltage, current, temperature, and state of charge, trying to keep the cells inside safe operating limits. And this is the deeper idea. A lithium-ion battery works because it separates two journeys. Lithium ions travel through the inside of the cell. Electrons travel through the outside world. The battery makes those electrons do useful work before the two paths meet again. When you recharge it, you spend energy to reset that chemical arrangement. So the object in your pocket is not a container full of electricity. It is a carefully controlled chemical system. repeatedly moving ions, redirecting electrons, and balancing energy against stability. And every time the percentage on your screen rises or falls, that invisible system is moving with it.